All right, good morning, guys. This is our last section of circle stuff that we're going to be covering. We're actually almost done with October, too, so it means the semester is getting even closer to being done. All right, but we're kind of leaving the world of angles here, and we're going to talk about segments inside circles. All right, so we got three different types that we're going to be looking at here. The first one we're going to look at is called the chord segment theorem. All right, if you notice, guys, we've got two chords here. So we have chord AB, and we have chord we use this one. So chord AB, and then we've also got chord CD. So those are my two chords. Now, the chord segment theorem says, and I know you guys can read, we'll still read through it. If two chords intersect in the interior, so interior meaning inside of my circle, all right, so we've got interior, that's key, then the product, now if you guys remember, product means multiply. Product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Now, the way that I remember this, and I'm going to put this little note underneath here, is anytime you're dealing with chord segments, that means you're doing piece times piece. All right? And that's kind of the way that I kind of remember it. With chords, it's piece times piece. All right, so if we look back over here, all right, so this first chord, chord AB, all right, the two pieces of that chord would be AE and BE. So when we say piece times piece, we're talking about EA times EB. So those two pieces times the other two pieces of the other segment, which would be EC and ED, those would be equal. So EC times ED should be equal to EA times EB. So piece times piece equals piece times piece. All right, we're going to look at an example for each of these that we do. So first example, I actually got two of them. All right, so we have chords JN and chord KM intersect inside the circle, find the value of X. All right, so I've got two chords that intersect. All right, so if you guys remember, and I'm going to type this because it's easier for me to type and probably more legible, it's piece times piece for chords. All right, so that's key there. It's something we have to make sure we remember. All right, so that means, so let's take the first one. Let's do this in blue. So let's take the first chord, which is JN. So the two pieces of JN are 10 and X. So it's going to be 10 times X equals the two pieces of my other chord, which would be chord KM, are 8 times 5. So piece times piece equals piece times piece. All right, so now I just go through and simplify. All right, so 10 times X is 10X. 8 times 5 is 40. So let's divide by 10 on both sides. Divide by 10 on that side as well. 40 divided by 10, well, that is 4. So the value of X is 4. Now, if they ask for the length of Jn, we would say, well, that's 10 plus 4, which is 14. All right, so y'all take a quick second. All right, Ms. Miller, if you wouldn't mind pausing it, take a quick second, and you guys try this next one. Once everyone's done, we can come back together. All right, so let's look at this next one together. All right, so I got my two chords. So I got chord MP, and I've got chord NO. All right, so those are my two chords. Wow, those are amazingly straight lines. Impressive. All right, so remember, with chords, all right, remember it's piece times piece. All right, so my two pieces, let's take the first ones, let's take MP. So the two pieces are 3 and 8. So 3 times 8, that should equal the product of my other chord. All right, so which is going to be 4 times X. The two pieces multiply together. So 3 times 8 is 24. 4 times X is 4X. If I divide by 4 on both sides, 24 divided by 4, will that do be 6? There you go. So if you remember 3, if you see it, 3 times 8 is 24, 4 times 6 is 24. So that should be equal to each other. Cool? All right, so that's the chord segment theorem. So if anytime you're seeing chords, it's piece times piece. All right, the next one we're looking at is called the secant segment theorem. All right, so remember, chord is piece times piece. All right, so we're going to have kind of a little hint or a little example for us to kind of see what this one's going to be. Now, secant segment theorem. We have two secant segments. So notice secant, remember, guys, means I've got a chord, a segment, a line, or ray, anything like that that touches the circle twice but continues outside. So I've got, in this case, I've got secant EB and I've got secant ED. All right, so those are going to be my two secant pieces right here. All right, if they share the same endpoint, aka they intersect outside the circle, then the product of the length of one secant segment and the length of its external segment, external just means outside, all right, equals the product of the length of the other secant segment and the length of its external segment. Now, the kind of rule or the helpful hint that I use for secant segments, externals means outside. So we take the outside piece times the length of the whole segment. All right. So notice it says up here, guys, the product of the length of one secant segment. So the entire length of the secant segment times its outside piece. So the way that I remember it's outside times whole. So chords are piece times piece. Secants are outside times the whole. So if you look over here again, all right, so EA times EB. So EA is my outside piece times EB is the length of the whole thing. So outside times whole equals the outside piece times the whole piece. All right? So let's look at a couple examples real quick. All right, so the first one. So again, they're secant, so I'm going to use this outside times whole rule. All right, so let's look at this first one here. All right, so I've got two secant segments that go outside. All right, so let's just look at this. Let's look at this bottom segment first. Doesn't matter which one you do first. All right, so it's outside times the whole. So the outside piece here is 15. So it's 15 times. The length of the whole segment is 15 plus 9. And that's key. It's not 15 times 9, it's 15 plus 9. That's the length of the whole thing. All right, so the outside piece times the whole equals, now let's look at my other segment. All right, so my other segment's right here. My outside piece is 12 times the length of the whole thing is 12 plus x. Again, that's key. All right, so now if we look at my left-hand side, so 50, you can do this one of two ways. You can take the 15 and distribute it to both pieces, or you can just add 15 and 9. That's 24. So this would be 15 times 24 equals, and over here we would need to distribute. So there and there. So 12 times 12 gives me 144 plus 12 times x is 12x. And on the other side, we've got 15 times 24, which will give me 360. So 360 equals 144 plus 12x. Now it just becomes an algebra problem. Subtract the 144 over. You get 216. And last but not least, divide by 12. And you get your x value to be 18. Boom. Cool. All right. Well, let's try the second one. The second one, I think we're just going to set up. We're not actually going to go through and try and solve it because it's a quadratic. We haven't really talked about how to solve quadratics yet, but let's just set it up anyways. All right. So right here, we got two secants. So again, they intersect the circle twice. Keep going outside, so they're secants. So I got to use this rule for outside times whole. That's the rule I'm going to use here. All right, so let's just take this bottom segment first. Again, you can take the top one first, doesn't matter. All right, so the outside piece times the whole. So the outside piece is 7 times the length of the whole thing is 7 plus 12 equals, now let's look at the other part. The other segment is outside piece, which is x, times the whole thing, which is x plus 10. All right, so the left-hand side, 7 plus 12 is 19. Right, that's so 7 times 19. Let's take that and distribute it through on the right side. So x times x is going to give me x squared plus x times 10 is 10x. All right, so let's go back to the left-hand side. So 7 times 19 gave us 133. That's x squared plus 10x. Now, if you were going to solve it, we're not going to. When a quadratic, you want to set it equal to 0. So I want to take this 133 and subtract it over. So we're going to stop right here at 0 equals x squared plus 10x minus 133. All right. Next semester, we're going to look more at solving quadratics, so it's not really going to be our focus this semester. But if you guys knew how to, we would go through and do it. But since we haven't really talked much about it, we'll stop right there. All right, so again, secant is outside times the whole. So outside piece times the length of the whole piece. All right? All right, this last one uses secant again and the tangent. All right? So the rule here, the nice thing is here, guys, is we already know what the secant is. That's outside times whole. So the only piece we're adding in here is tangent. All right, so let me just kind of write this up here. So we know that secant is outside times whole. All right, and then the rule for tangent, we'll put that piece over here. For tangent, you're taking whatever the length is, and you're squaring it. All right, so again, we already know what the secant is. I'll keep that over there. All right, secant is just going to be outside times whole, and for my tangent, I'm going to take whatever that length is and square it. So that's what this is saying up here for the tangent secant theorem. Secant outside times whole, tangent, you square your length, and then chord, we're not going to see any more of those, except for what we were doing earlier, is piece times piece. All right, so let's look at a couple examples. First one, it says you're standing at a point Q about 9 feet from a large circular tent. The distance from you to a point of tangency at point P is 24 feet. Estimate the radius of the tent. So notice I've got this radius right here that I'm looking for. All right, so if you notice, I've got a secant right here. QT is a secant. QP is a tangent. So that's what I'm going to use for secant. It's going to be used for tangent. Set them equal to each other and solve. So secant is outside times whole. All right, so let's look at that first. My secant, my outside piece is 9 times the length of the whole thing, which is 9 plus R plus R plus R plus R. All right, and then my tangent, I'm going to take whatever the length is, which in this case it's 24, and I'm going to square it. All right, so now on the left-hand side, we can go through and simplify it. All right, we're trying to find my radius of my tent. I can simplify that. R plus R is 2R. So this is 9 times 9 plus 2R. And we can go ahead and find out what 24 squared is. 24 squared is 576. All right, so now on the left-hand side, we can distribute, boom, and boom. So 9 times 9 is going to give me 81, plus 9 times 2R is 18R, equals, and I've got my 576 over here. Comes down to a basic algebra problem now. Subtract your 81 over, gives you 495. So I've got 18R equals 495. Last step's divide by 18. You're going to get your radius of that tent is approximately, well, it's actually exactly 27.5 feet. All right, so again, your secant segment, you're going to do outside times whole. Your tangent segment, you're going to do whatever its length is and square it. Cool. All right, y'all try this one for me real quick. So y'all pause this one for me, and if you guys need a little extra time when we come back, you can always pause it again. All right, so once again, we've got a tangent, and we've got a secant. All right, so what I'm going to do is we need to go back here real quick. We're going to copy that over just so we've got that. All right, just to remind us for that part, and then let's get this one as well. Oops, wrong way. All right, so I got a secant and a tangent. So again, secant, we have our outside times whole, so let's look at that part first. All right, so my outside piece is 9 times the length of the whole thing is 9 plus x equals my tangent is whatever the length of the tangent is squared. So right here, my tangent has a length of 15, so I'm going to take and do 15 squared. All right, so on the left-hand side, let's take a distribute. Boom, shakalaka. So 9 times 1 is 80, or 9 times 9 is 81, plus 9 times x is 9x. 15 squared give us 225. All right, so from here, we just want to go through and subtract a basic algebra problem. So if we take 225 minus 81, that's going to give us 144. So I've got 9x equals 144. We'll divide it by 9, and my x value will be 16. All right, so again, secant segment, outside times whole, tangent segment, take whatever its length is and you square it, and then chord, it's just piece times piece. All right, and that's it, guys. All right, now that's going to wrap up circles. Now tomorrow, if I'm here, we'll look at it. If I'm not here, you're going to look at it. All right, you're just going to go through and make what we're going to call a circle flip book. It's just really a what we would call a graphic organizer to kind of help organize all the stuff that we've talked about with circles. Because there's a lot of stuff about the angles, you got stuff about the arc length and sector area, and then now we've also got stuff with segments and circles. So there's a lot that's going to be on this test. All right, but this test is going to be on Friday. All right, so please, please, please make sure you're going back and you're studying all those different parts. Because remember, the angles, we had central angles, inscribed angles, angles inside, angles outside, angles on. We had our arc length, circumference, area, sector area, and now we've added in our segment pieces with chords, piece times piece, secants, outside times whole, and tangents, which are the length squared. A lot of stuff with circles, a lot of material on this test, so please, please, please make sure you are studying and practicing all those different concepts. All right, hope you guys have a wonderful day. You guys have the rest of the period to work on your segment lengths in the circles practice. Remember, guys, the answer keys are posted online for you to check your answers, not to copy them, but to check them to make sure you are doing it correctly. Have a wonderful day, guys, and I will talk to you later.